Okay, so let's look at number one. It says find the volume of the solids whose bases are bounded by the graphs of y equals x plus 3 and y equals x squared minus 3, with the indicated cross sections taken perpendicular to the x-axis. Okay, so a couple things. First of all, I'm going to be toggling through here and here for the information. So let's go ahead and write down our equations for number one. The first one we have that I will write in red is y equals x plus 3, okay? And then in blue, I have y is equal to x squared minus 3. And it's perpendicular to the x-axis, which we could also write as parallel. So parallel to the y-axis. So perpendicular to the x is parallel to the y-axis. Okay, all right, so in the first one, we're going to do squares, okay? And then the second one, we're going to do rectangles of height of 1. So rectangles of height 1. All right, so now that I have that, let me go ahead and show you that where I just wrote it. So I have my equations, and we're going to go ahead and set them up. I'm going to draw a quick picture, and I want you to watch these videos and see how to get that practice. So we have the x, and we have the y, and then we have like this z-axis coming up. Okay, so this z-axis is gonna come up from the graph, like here, and then we can continue it if we want, and it kind of goes underneath the page, if you will. Okay, so here's the y-axis. Again, this is like from an aerial side view. Let's go ahead and write it down. So we have y equals x plus 3. So that's a linear function shifted 3 units up. So it goes here, and then 1, 2, 3. It also goes here. And if I were drawing it, it would look something like this. Okay, so just a little bit off. Let me try that again. Okay, so there's the y equals x plus 3. Okay, so now we're going to do the x squared minus 3. So shifting down 3 units with a quadratic, and that's where my vertex will be. It's going to shift, it's going to go upward. So it all depends on like where does it go upward and touch this other red function, this linear function. Well, you could always use your calculator to help with that if you'd like. So you can go to the graphing calculator, and let me clear that from previous work. And then we'll press tab, and we have x plus 3. Okay, and our second one, we'll press tab, we have x squared, and then this one's minus 3. So it looks like this, and you can see that right here, about negative 2, 1 is where they cross, okay? So if I go back to my graph, I kind of almost got it correct, but I can take it and change it up just a little bit. We're at negative 2, 1 is where it kind of crossed. Oops, let me go ahead and draw it like this. And then it went to what looks like, I don't know, 3. When x was 3, it looks like that's whenever it intersected that red graph, okay? And then we can come over here, and then it kind of goes on forever. So that if you're looking at it from an angle, the base is all of this area here in between these two functions. Okay, that's the base in between the red and the blue graph. And sprouting up like plants, if you will, are going to first of all be squares. Okay, so since we're looking for the volume, we know that the integral of an area is going to yield volume of some kind. Okay, so we just have to think, what are the area cross sections for a square? Well, the area is side squared, and then rectangles, the area is base times height. But since the height is going to be a constant, it's always 1, we can say area is base times 1, because it's always 1. Which then we can just say, well, since it's just 1, this particular equation is just going to be a equals b. Okay, and remember, this a of x that we're kind of like finding, this is what's going to replace over here And this a, whatever we find, that's what we're going to put in for our integrand as far as showing what pieces of that equation do we need. Okay, so this is side squared. So when I build it, it's going to be like side squared and dx or dy. Okay, because these are parallel to the y-axis, these are going to be vertical slices. Okay, vertical slices are dx. If it was parallel to the x-axis, those would be horizontal slices, and those are dy. So that's how you at least get it started as far as knowing what you're in respect to, okay? So now we got to come up with an equation that shows the length of a side. So let me go ahead and grab, let's say, I'll grab this purple one here. Let's make it a little bit more visible. And what we're going to show is these up and down vertical slices, but on a three-dimensional plane, is going to be like if you were looking from an angle, it's going to look something like this. So that's the up and down, okay? To where the top function, where it touches here at red, let me go ahead and put a black dot. That's the top function, and the bottom function is going to be blue. Again, you're looking at it like from up here, like an aerial view, and you're looking down on it right there. Okay, so there's your nose, there's your smiley face. You're looking it down like that. So the top function is the red, and the bottom function is the blue. And that would be the distance of that purple line that I just drew. Okay, so let's put this as the length of that purple line is going to be all of your side, and it's going to be squared because it was side squared as far as our equation is concerned. Okay, so let me go ahead and change that. So all of that side squared, we know it's dx because they're parallel to the y-axis. And now I just need to do some kind of top minus bottom. So I need some kind of top minus the bottom to show the length of this purple line that I just drew. Okay, so the top function is x plus 3. The bottom function is x squared minus 3. And this is the setup for our squares. We have the entire side was squared, which is all of this is the entire side, and it's been squared. Okay, so that's the setup. And if you plug that into your calculator, you can go ahead and get the answer and then just put it in as far as over here on WebAssign to get the correct answer. The default is 3 decimal places if it gives you that. But nonetheless, let me just quickly show you some practice as far as putting that in the calculator. So we have the integral, and it's going to be from, oops, I got to do that part. I need to see where did these intersect each other as far as the blue graph right here intersecting the red, and then over here as well. Because this will tell me what is the x and what was this x. What was the low to high? Otherwise, the a to the b value. Okay, and that's what we're going to put here and here in our integral. Okay, so let's go ahead and find these set equal to each other. If we did it by hand, it'd just be x plus 3 is equal to x squared minus 3. And that's just algebra 2, where you're doing quadratic. And then you would subtract, so you have minus 9. And these are a little bit weird numbers as far as factoring them by hand. So I'm going to go ahead and go to the calculator. Okay, so let's say menu 3-1. And we're going to set x plus 3 is equal to x squared minus 3, and we're going to tell it to solve for x. So we have negative 2, and we have a negative or a positive 3. And I see why I made a mistake over here. This actually should have been minus 6. And that makes more sense because it's x minus 3, x plus 2, so that my zeros are 3 and negative 2. Okay. So negative 2 is this one right here for a. That's the x value. And positive 3 is my upper bound. So let me go ahead and write that in my integral equation. And then now I can say what it actually equals as far as an answer is concerned. Okay, so let's go to the calculator. We're going to do the integral from negative 2 to 3. Whoops, not e, 3. And it's going to be this side squared, whoops, in vertical slices, which is dx. Okay, so we'll say the top minus the bottom. And now we're just going to jump in there and put what we had as the top of x plus 3. And then we have the bottom being x squared minus 3. And then we get an answer of 625 over 6. That will be the answer here, which is the volume. Okay, so let's go ahead and write that out. It is 625 over 6. We'll say cubic units. Okay, it didn't put like inches or feet. Let me go to make sure. Yeah, it did not. So that's going to be the answer there. If you decided to do this and show the decimal, it's control enter. I would write 104.167. Okay, you can either put 0.166 or 0.167. I'm a rounding kind of person, so to 3 decimal places is the default minimum. Okay, so now that we have that, let's go ahead and go to our rectangles now with the height of 1. Okay, so let me go ahead and see if I can minimize all this. My eye kind of fell off there, no worries. And let's move this z-axis to be over here. All right, so let's keep going. Rectangles with a height of 1. Well, we know our equation became just b. Okay, and b is the length of this base, which we already have drawn in purple. Okay, so the length of this particular base is already drawn. So it's very similar to A, but we're not going to square anything. We're just going to say the length of B is what we have over here as far as that purple length already drawn out. So let me just copy this, save myself a little bit of time, and I'll paste it over here. But this time we are not going to square it because it's not B squared. Okay, it's just B all by itself, which is the distance from the top minus the bottom, the red minus the blue. Okay, so when we put this in the calculator, let's see what cubic units we will get as far as an answer is concerned. So I can just go up, grab my previous one that I typed in, scroll back and click out or subtract that squared piece. Now you notice it kind of disappeared these parentheses, and the reason why is because there's just an understood positive that exists right here where the cursor is blinking, and it knows it doesn't need it. So it simplified it out from the previous problem. No worries, there's my answer right there. So 125 over 6 cubic units. And again, if I wanted to put that as a decimal equivalent, I could just go back, copy my previous answer, and put control enter to get my decimal answer. So let me show you that real quick. Just press enter to copy, press control enter, and 20.833 would be the answer there. Okay, so 125 over 6 units cubed is the answer. And that's how you do both parts of number 1 from the homework. All right.